Whoa there, we're still not ready for the periodic table. Hey guys, and welcome to your first lesson in actual chemistry. So I'm just going to write chemistry on the board so we can go from there. In this part, we're going to learn about matter. And I'm going to draw a definition of matter right here. I'm going to type it up actually. Matter is best defined, if I could get this to work, I'm going to have to change the color, aren't I? I'll change this to white. Matter is anything that has mass and takes up space. Alright, that's a pretty exciting definition. So let's make sense of it. Matter is anything that has mass and takes up space. So you, sitting there on your computer, sitting your butt down on top of a chair, or on the go on your iPod, however you're watching this video. You sitting right there, you are matter. Why? Because you take up space. A part of you exists in the. It's hard to explain. You exist. You take up space. If you weren't there, you'd be able to fit 20 cows in your place, depending on how fat you are. That is not a fat joke on you, though. So you take up space. You exist. Matter, anything that has mass. If you got on a scale, depending on how heavy you are, you'd weigh something in grams. You'd weigh a certain amount of grams. You take up space. So you are matter. Light. Light is not matter. Not matter because it doesn't weigh anything. There's no mass of light, and there's a reason for that, but that goes beyond the scope of chemistry. There is no light. Light does not have mass. Light does not have mass because it's not matter because it doesn't have mass. Rather, it takes up space. It does take up space. Believe it or not. Well, yeah, it does. Yes, it does take up space. I was thinking ahead. Actually, we do kind of learn that matter has mass and takes up space, but light takes up space. But because it doesn't have mass, it's not matter. Let me think of something else. Let me think of paper. Paper is matter. Anything that takes up space is matter. And there are 4 types of matter, 4 states of matter. I'm gonna write this 4 states of matter, but only 3 are available, or visible rather, on Earth. 4 states of matter. The first one, I'm gonna get another text box up. The first state is solid, second state is liquid, third state is gas, and fourth state is plasma. Now I'm going to explain the significance of this chart right here, right now, in front of all of you guys. Solids. You guys are all solids. And a definition of solid is anything that's compact. So let's say I had an ice cube. A white ice cube. Or, yeah, it's an ice cube, guys. Actually, I'm going to use blue instead. Let's say I had an ice cube. And it's kind of glossary. I can't draw. That would be solid because it's compact. A liquid. Well, a liquid would be water, so drawing water, liquid, anything that flows. Gas is really, we're going to draw a container, we're going to say we had water, and then gas is really spread out. There's gas all around you. The example is air. Air is a gas. And plasma. Plasma does not exist in this, in our Earth, and we really don't have a good, picture or anything of it, so I couldn't even pull one up from the internet. But plasma is gas that is so hot it behaves like a liquid, and we'll learn how that's possible when we study chemistry a little bit later. Behaves like a liquid. There we go. So gas that is so hot that it behaves like a liquid. Now I have a question for you. What is the most plentiful state of matter in the universe? You'd think gas, right? However, it is plasma. The reason is, when we think about the universe, we're thinking about matter. But as you'll learn later, it's really weird because a bunch of the universe isn't exactly matter. It has mass, but it doesn't take up space. How is that possible? And some things have mass, but don't take up. Some things take up space, but they don't have mass. Rather, isn't that weird? Yes, that's true. That's what dark matter is. If you ever heard of that, dark matter. It takes up space, but we don't really weigh it. It's we have no idea what it is. But yeah. So a lot of this is actually plasma. The universe is actually a lot of plasma. However, in our Earth, the most plentiful amount of substance, I believe it's either a liquid or a gas. It's debatable. It's what the definition of our Earth is. If you're defining the entire atmosphere, I guess it'd have to be a gas. Otherwise, it'd be a liquid. Reason being is because the Earth is 75% water. 75% water. But the universe, the universe, our world, all around us, gas is flowing around in the form of, you guessed it, air. Alright, now I have another definition for you. So we basically figured out the 4 states of matter. I gave an example of each. We figured out what the heck matter is. Now it's time for me to throw another curveball on you. We'll talk about what a substance is next. A substance. Oh, that sounds iffy. Substance. We're going to say substance is matter that always has a uniform and definite composition. Now, what I mean by that is, it's at any given moment, it's always going to be something. It's always going to be one specific thing. It's always going to be either gas. It's always going to be. It always has a uniform and definite composition. It's always going to be made up of the same particles. Now, an example of this is table salt. That is a substance, and you might not have known this. We're going to go back up to the periodic table, but table salt is really one atom of sodium and one atom of chlorine. We're going to go over what an atom is. It's one sodium and one chlorine put together. It's NaCl. That's the formula for salt. The salt that you eat at the dinner table. It's made up of these two elements. It's nothing weird. It's just made up of these two elements. And table salt will always have a uniform composition. Even if you throw it on the ground and smash it into different pieces, it will always still have the sodium and the chloride put together. However, actually, I really don't want to confuse you by giving you something that's not a substance. Carbon dioxide. An emphasis right here is always, by the way. Carbon dioxide. CO2. Let's say I'm thinking right here. Let's say I decided to Actually, let's not go into this. For the purpose of everything that you guys know, it's all substance. I was thinking about explaining it, but I think I'll come back to this another day. This is a little over the top for you guys right now. Now, properties of matter. So, if something's matter, it will always exhibit, it should exhibit these qualities. Properties of matter. And I'm going to type these because I feel like writing them would be killer. So I'm going to drag this right here, make this yellow, and let's go with this. Properties of matter. It has mass, and it has volume. It has a melting point, and it has a boiling point. It has color, texture, and density. And on top of that, it has a chemical composition. It means it's made up of chemicals. What chemicals? Well, you guessed it. Oh. I'm going to drag this over. What chemicals? Oh, you guessed it. The chemicals that make up this beautiful periodic table that you see right here. So, it has mass and it has volume. Let's take a look at one property of matter. And we're going to use, let's say I had a jar. It measured 60 cubic units, 60 cubic centimeters. And these are all fake, by the way. And let's say I filled this up to brim, up to, let's say I had 30 grams of the NaCl, of the sodium. And let's say I wanted to it takes up 60 grams, 60 centimeters cubed, but the amount of volume that's taken up by this table salt is only 42. I don't know. See here. So this is a prime example of some matter that we can figure out the mass, volume, melting point, boiling point, all that good stuff. well, most of them. Some of them I'm gonna have to give them to you. Um, so we have that the mass of this sodium, of the NaCl, the sodium, it has 30 grams. It's 30 grams. The volume, how much it takes up 42 centimeters cubed of space. That's why we come back to where is it? It has mass and takes up space. It has 42 centimeters cubed of that. We're getting quite large, quite stretched out. I guess I'm gonna have to cut it out after this. The color, as you all know, is white, and I definitely just did that in red. I believe actually that there's games that help you test your mental power by writing words like this and asking you to say the color that's written, not the color of the text. Pretty cool. The texture, it's always kind of roughish, and the density we're gonna have to go over right now. Density is defined as mass over volume. So you always take the mass and you divide that by the volume. So the density of this would be 30 divided by 42, which goes out to 15 over 21, which can further be divided great to 5 over 7. I believe I did that right. I might not have. No, it's 5 over 7. Let's see here. Divide by 7. Ooh, we can't divide by 7. Divide by 6. So I did that right. Yep. 5/7. Okay. It has chemical composition. Well, we already knew that. I gave it to you. It's made up of the elements sodium and chloride. So basically what we get right here is that matter, I'm going to do a quick review and call it apart. Matter is anything that has mass and takes up space. Light is not matter, but you are matter. We have 4 states of matter. We have solid, liquid, gas, and plasma that only exists in the universe. The most plentiful state of matter in the universe is plasma. However, on our Earth, depends on your definition, it could either be gas or a liquid. And plasma, by the way, is gas that's so hot that behaves like a liquid. Substance is matter that always has a uniform and definite composition. So everything on the universe, basically, everything in our planet, rather, I keep on saying universe, everything in our planet is substance. Property of matter. Properties of matter, it has mass and volume, and I gave an example. The mass of this will be 30 grams, because we weighed it. The volume of this will be 42 centimeters cubed. Could you figure out how much of the cylinder, of the jar, rather, that the salt took up? We have color, texture, and we have density. The color is white, the texture is kind of rough, and the density is 5 over 7 because we did a crazy thing. For the record, I believe these measurements are incorrect and it wouldn't do that. So, yeah, that's all I really have for this part. In the next part, we'll go over, I'm gonna delete all this. Yay, the periodic table, however, is eternal. It never goes away. So in this part, we talked about matter. And in the next part, we'll go over properties of matter. Alright, that'll be pretty intense. So that'll be part 4. I look forward to that. It's coming up in a theater near you. Alright, see you guys.